Megan asked children from two different schools, how do you travel to school? Here are her results. So we have a pie chart for Foxwood School and a pie chart from Midtown School. Megan says the number of children walking to Foxwood School is more than the number walking to Midtown School. Is she correct? Explain how you know. Well, let's find the number of children walking to Foxwood School. We can see that for walk we have half of the pie chart, and we know that it's half because we know that this line here is a straight line because we have two right angles for car and cycle. So we can find half of 80. Remember, to find half we can divide by 2, so divide by the denominator, and 80 divided by 2 is 40, so we know that 40 children walk to Foxwood School. So now let's find out how many walk to Midtown School. On this pie chart, we can see that we have a right angle for walk, and remember, a right angle is a quarter of a turn. So because there are 240 children in Midtown School, and we have 1/4 that walk, we need to find 1/4 of 240. To do that, we divide by the denominator, and 240 divided by 4 is 60, because 24 divided by 4 is 6, and if we have an end zero in our dividend, we need an end zero in our quotient. So 1/4 of 240 is 60. And that means that Megan is wrong. 1/4 of 240 is more than 1/2 of 80. So 60 children walk to Midtown School, but only 40 children walk to Foxwood School. Now, at Midtown School, 1/3 of children travel by car. The number of children who cycle is the same as the number who go on the bus. How many children cycle to Midtown School? So we know that 60 children walk to school. We found that in the first part of the question because 1/4 of 240 is 60. Now we need to know how many cycle. We know that 1/3 travel by car. So if we work out 1/3 of 240, we can divide 240 by 3, and that gives us 80, because 24 divided by 3 is 8. So we know that 60 walk and 80 go by car. We also know that the number who cycle is the same as the number who go on the bus. So what we can do is work out how many children either go on the bus or cycle. There are 240 altogether. So if we subtract 60 and then 80, so subtract 140 altogether, that gives us 100. So because there are 240 children altogether, and 60 plus 80 plus 100 makes 240, we know that 100 children either go by bus or cycle. Now because the number is the same, what we can do is divide 100 by 2, and because that's 50, we know that 50 children must cycle to Midtown School. Look at this quadrilateral. So remember, a quadrilateral is a shape with 4 sides, because quad means 4. You can draw one line on the quadrilateral to make 2 triangles. So here they've joined this corner, and because they've done that, they have a triangle here, so a 3-sided shape here, and a 3-sided shape here. Use a ruler to draw a line in a different place on the quadrilateral to make 2 triangles. So here they've joined opposite corners, so if we pick a different corner, we can just draw a straight line to the opposite corner, and that gives us a triangle here and a triangle here. Now draw one line on the quadrilateral to make a quadrilateral and a triangle. So we need to make a 4-sided shape and a 3-sided shape. Well, if we draw the line here, we have a 4-sided shape on the left and then a triangle on the right. Now draw one line on the quadrilateral to make 2 quadrilaterals. So we need to make 2 4-sided shapes. If we draw a line here, we have a 4-sided shape on the left and we have a 4-sided shape on the right, so we've made 2 quadrilaterals. Write these temperatures in order from hottest to coldest. So here we can see that we have mostly positive temperatures, but we also have -12 and -2. And if we have a negative temperature, that will always be colder than a positive temperature. So our hottest temperature is the largest positive number, so that's 92 degrees, and it's useful to cross them off as we write them. Then the next largest number is 73, then we have 37, 12, so we have -2 and -12. So -2 is next, and then our coldest temperature is -12. -12 is colder than -2 because 12 is larger than 2. And remember, on a number line, we only need to go back 2 from 0 to get to -2, but we need to go back further. We need to go back 12 to get to -12. Jack has 2 square-based pyramids that are the same size. He sticks the square faces together to make a new 3D shape. How many faces and how many edges does his new 3D shape have? So let's think about what Jack's done. He's got 2 square-based pyramids and then he sticks them together to make a new shape. So these faces here are going to be stuck together, which means that these faces will be on the inside of his shape. So these now can't be seen. And we can't have faces on the inside of a shape, so really these 2 faces will no longer be faces. So what that means is that we have 4 faces at the top. We can see 2 of them, and we know that there will be 2 behind because it's a square-based pyramid, and we have a face connecting each part of the square to the top, and we will also have 4 faces on the bottom. So altogether, if there are 4 faces on the top and 4 on the bottom, there will be 8 faces in his shape altogether. Now we need to know how many edges the shape will have. We'll have 4 edges at the top because 4 lines need to connect the top of the pyramid to each of the corners of the square, and we'll have 4 edges at the bottom as well. Now round the middle we'll have 4 edges. Now you might think, why don't we have 8 edges? Because we've got 4 edges here and 4 edges here. But remember, Jack is sticking these square-based pyramids together, and if edges are stuck together, rather than 2 edges, we will only have 1 edge. So 4 top, 4 middle and 4 bottom, so that's 12 edges altogether. Here are fractions. First, we need to circle the improper fractions. So remember, an improper fraction is a fraction that's larger than 1. So a fraction with a larger numerator than denominator. So 4 halves is an improper fraction because 4 is larger than 2. 10 is larger than 3, so 10 thirds is another improper fraction. And 6 is larger than 4, so 6 quarters is our other improper fraction. Now, which fraction is equivalent to 1 1/2? So here, they've given us a mixed number. But as they've written improper fractions rather than mixed numbers, what we can do is turn our mixed number into an improper fraction. So 1 times 2 is 2, plus 1 is 3. The denominator stays the same, so 1½ is equivalent to 3 halves. Now which of these are the same as 3 halves? Well, it's clearly not 4 halves, because 4 halves and 3 halves are not the same. They're not equivalent. Then we have a denominator of 3, but 3 isn't in the 2 times table. So let's see if 3 halves is equivalent, so the same value, as 6 quarters. 2 times 2 is 4, and when we find equivalent fractions, what we do to the denominator, we do to the numerator as well, and 3 times 2 is 6. So that means that 3 halves is equivalent to 6 quarters. And remember, 1½ is the same as 3 halves. Now, which 2 fractions are equivalent? Well, let's see if 2/5 and 4/10 are equivalent. We can change fifths into tenths by multiplying by 2. 5 times 2 is 10, and if we do the same to the top, 2 times 2 is 4. So that means that 2/5 and 4/10 are equivalent, so fractions of the same size, or of the same value. Liam has 2 different sizes of rectangle, so we can see that he has a longer rectangle of 45 and shorter rectangles of 20 centimetres. He makes this pattern with them. Calculate the lengths of A and B. So what we can do, first of all, is work out the lengths that he's made. On this top row, he has 2 of the 20 centimetre rectangles. So 2 times 20, or 20 plus 20, is 40. So we know that this length on the top row is 40 centimetres. Then on the middle row, he has just 1 of his larger rectangles, so that's 45 centimetres. And on his bottom row, Liam has 3 of the 20 centimetre rectangles. So that's 60 centimetres altogether, because 3 times 20, or 20 plus 20 plus 20, is 60. So now that we know the lengths that he's made, we can calculate the lengths of A and B. We can see that A is the difference between 40 and 45. So A must be 5 centimetres, because 40 centimetres plus 5 centimetres makes something the same length as 45 centimetres. Then for B, we can see that that's the difference between 45 and 60. So 60 minus 45 is 15, because 45 plus 15 is 60. So the length of B must be 15 centimetres. Write the missing numbers. Something is 1,000 more than 19,999. So we need a number that's more than this number, so we need to add. And 19,999 plus 1,000 is 20,999. So that's our missing number. And we could use column method to work this out, but we can do it mentally by spotting that 19 plus 1 is 20, and then the hundreds, tens and ones digits will stay the same because we're not adding any hundreds, tens or ones. Now 39,001 is 1,000 more than what number? So here we need to subtract, because this number is more than the number in this box, so this number here will need to be smaller. Now 39,001 minus 1,000 is 38,001, so that's our missing number. We can spot that it's the thousands digit that's changing, and 9 minus 1 is 8, and then all of our other digits stay the same. And it's useful to check that what you've written makes sense, because most of the time, when children have got it wrong, it's because they subtracted up here or added down here. So check that what you've written makes sense. We have a larger number is more than a smaller number, and that makes sense because this number is larger or more than this number. And again here, we have a larger number is more than a smaller number, because this number, 39,001, is more or larger than 38,001. Circle the fraction that is greater than 1/2, but less than 3/4. So first we have 7/8. That's not our fraction, because 7/8 is more than 3/4. We can see that 3/4 is equivalent to 6/8, but we need a fraction that's less than 3/4, so less than 6/8. Now it's not 2/5, because that's less than 1/2, and we need a fraction greater than 1/2. 2/5 is the same as 4/10, but 1/2 is the same as 5/10. So we need a fraction that's greater than 5/10. Now it's not 1/3, because that's less than 1/2. Now you might think it's more than 1/2, because 3 is larger than 2. But remember, the larger the denominator, the smaller the fraction. We can see that 1/3 is equivalent to 2/6, but 1/2 would be equivalent to 3/6. And we need a fraction that's greater than 1/2, so greater than 3/6. So now let's try 5/8. That's going to be our answer, because 1/2 is equivalent to 4/8, so 5/8 is greater than 1/2, greater than 4/8, and 3/4 is equivalent to 6/8. So 5/8 is less than 3/4, because that's less than 6/8. So we need to use equivalent fractions to find our answer. Now we could just move on to the next question, because it says circle the fraction, not circle the fractions. But just to check, let's look at 3/6. That's equal to 1/2. 1/2 is equivalent or the same as 3/6, but we need a fraction that's greater, so more than 1/2. So our answer isn't going to be 3/6, our answer is 5/8, because using equivalent fractions, we found that that's more than 4/8, but less than 6/8.